Yes, actually, I'm going to explain the standard Ethernet. Okay, the standard Ethernet. Okay, it was created in 1976. Okay, at the Palo Alto Research Center. Okay, and it is going to evaluate the fourth generation. Okay, that is nothing but our Ethernet generation. Okay, so what are that Ethernet generation? The first one is the standard Ethernet. The second one is fast Ethernet and gigabyte Ethernet, as well as the 10 gigabyte Ethernet. Okay, then standard Ethernet. Okay, it contains the 10 megabit per second. Okay, Mbps, 10 Mbps. Okay, then fast Ethernet, it contains the 100 megabit per second, and gigabyte Ethernet, it contains 1 gigabit per second, and 10 gigabyte Ethernet, it contains the 10 gigabit per second. Means for each and per each data or each information, okay, which is going to transfer from one to another. Okay, within that within that speed limit will be, okay, if it is 10 gigabyte Ethernet, okay, it have the 10 giga per second. Means the like means that the means that 10 gigabyte bit per second. Okay, it is going to miss that much fast, it is going to reach the particular data to particular destination. Means the speed of, okay, the speed it is going to elaborated here. Okay, means how much the speed of the each and every generation having. See, this is what the pictorial diagram, okay, they have shown. The next one is the MAC sublayer, means multiple access controller sublayer. The multiple access controller sublayer, okay, the main goal of our MAC sublayer means to perform the operations related to access method, and it is also, and it is also the frames of the data, okay, it is going to received from the upper layer, and after that it is going to passes that particular frames into the physical layer. Okay, that physical layer, it is going to encode it, that particular data into in the form of zeros and ones. Okay, that zeros and ones, it is going to send through the signal. Okay, so this is what our MAC sub layer. The next one is our 8.02 of Mac frame. Okay, our Mac sublayer, it contain the Mac frame. Okay, it is one of the some like sub part of that, that the Mac sublayer. Okay, so this is what the Mac frame. Okay, our Mac frame here, like usually it contains the seven fields. Okay, that is preamble and SFD, destination address, source address, length, PDU, data and padding, and CRC. Okay, see all the seven layers. Okay, it is going to contain our Mac frame. Okay, then what is the preamble? Okay, the preamble, it means initially it contains the 7 byte of information. Means 7 byte of information. Okay, each bit, it contain, it means each bit information is considered as a 1 byte information. Okay, like that it can have the 7 byte of information. The preamble, sorry, preamble have the capacity to store the 7 byte information at a time in the memory. Then our preamble, okay, it is going to alternate the 56 bit of data into the form of zeros and ones. Okay, means once it is going to alter the that particular bit or the particular data. Okay, at the receiver side. Okay, the receiver, it is going to receive the receive the particular upcoming frames. Okay, that it is going to enables to into the synchronize as the input timing of the another field. Means whatever the data it is coming, okay, at the receiver side. Okay, it is going to receive that particular data, and that data it is going to enables at the enables at the next bit of input timing signals. Okay, this is what our preamble method. Okay, then what is the SFD? SFD is nothing but start frame delimiter. Means it is going to start the frame, okay, without any limitation. Okay, means how much you want, you can send. Okay, if you want amount, a number of frames, okay, at a time you have to send, okay. So this is what the start frame delimiter. There is no any limitation of to sending the frame, okay. How much you want you can access the data, or how much you want you can send the frames to means you have to take the transaction. See, that's what our SFT. Our SFT, that field also, okay, it have the capability to store the 1 byte information at a time, okay. That they like that 1 byte information, okay, it contain the yeah, it contain the length, okay, it contain the length of that particular 1 byte information, okay, with the help of zeros and ones, okay. It's like if suppose, okay, they have given the sequence, okay, 00 something, okay, 0011, or 1011, okay, whatever it may be sequence, okay. At the end, okay, at the end, if at the end it is going to encode it with two ones, okay. You look at this diagram, okay, at the end it is going to encode it with the two ends, okay. See, it is going to encode it with two ones, okay. This particular data or this particular signal, okay, it is going to consider, or it is going to receive at the receiver side, okay. Means there is no here in this, means it is going to like give the information, or it is going to give the intimation to the destination or receiver, okay. So you have to receive the particular information, okay. If at the end, okay, it is not included with the 1 1, okay, suppose it may be a 00, okay, means it won't reach to the receiver, okay. So this is what our SFD technique. The next one is what is the DA, okay, means the destination address. The destination address, it contains the physical address of the destination station, and means that particular address or that particular data, okay, it is going to receive at the our receiver with the help of the packet. Our source address, okay, so the source address, okay, it contains 6 byte of information. It means that the length of the information, it contains the 6 bytes, okay. And it is also, it contains the physical address as well as the sender of the packet. Means it is going to contain the source packet at the sender side. The length or type, okay, the length of the information, it is going to hold the our length field. The Ethernet, okay, usually it is going to use this field as the type field, okay. This type field, okay, it is going to define the upper layer protocol using the our MAC frame, okay. Then our upper layer protocol, okay, it contains our MAC frame as well as the IEEE standards, okay. Is okay, everything it is going to it is going to use in the form of the length field, okay, to define the number of bytes of the data. So this is our length or type, okay. Then data, okay, the data is nothing but, okay, the data field, it is going to carry the data encapsulation from upper layer protocol, okay. Means the data encapsulation, it is going to happen at the upper layer protocol with the minimum of the 46 bit of length, or it is going to carry the 46 byte of information in that particular field. And the maximum will be the 1500 byte. Means minimum is 46, maximum will be 1500 byte of information it is going to hold that particular data field. The next one is CRC. The CRC is nothing but cyclic redundancy check code, okay. You know that why we use the CRC here, the cyclic redundancy check code, they usually it is going to detect our errors, okay, error mechanism first of all, okay, to detect or to prevent our error message or error data, so that we are using the CRC. Means whenever we have the redundancy, means whenever we have to adding the extra bit at the receiver side, okay. So it is it is going to helpful for the user to making the to making to address that particular error in the at the receiver side. So that we have to implement a redundancy concept also. Means we have to adding the extra bit at the receiver side. So this is what our cyclic redundancy check code. The next one is frame length. Okay, this is the second part of our Mac sublayer. The first one, like we saw the header of that, what is that, frame thing. Okay, second one is the frame length. So the frame length, okay, it contains the yeah, it is going to contain the